derivative of trig functions. Another thing to add to your list to memorize. What is the derivative? I'll derive one of them, of tangent x. So these things we have to memorize. Derivative tangent is secant squared. What's the derivative of the secant of x? It's secant of x tangent x. Now, I'm going to add two more, but the good news is very similar to this. So once you memorize these two, the other ones, you can finagle, massage it a little bit, whatever you need to do to figure out what the answer is. Cotangent x and cosecant. Will be very similar to this, except both will be negative instead of positive. So these two, the c is always negative. See the c here? Cotangent begins with the c, cosecant begins with the c. It's always a negative, the derivative. Derivative cotangent. Since the cotangent begins with the letter c, guess what? It's cosecant squared. The c's, I guess, only like to play with each other. So cotangent plays with the cosecant. Derivative cosecant, it's negative cosecant of x, cotangent of x. Similar to that one, except instead of secant, tangents, cosecant, cotangent. So the ones that begin with the c's, you always see c's on this end for them. It's always a minus too. I'll derive one of them just to show you the answer is the tangent. I'll take the tangent and derive that to see if the answer is secant squared. So make sure you memorize these. You'll need them for Calc 1, Calc 2, Calc 3. If you don't memorize them, you'll pay the price, especially in Calc 2. Because in Calc 2 is the reverse. We're going to say, who has a derivative of this? And you tell us what the function is. Who has a derivative of secant squared? And you better know the answer is tangent. That's Calc 2. We do the reverse, antiderivative, opposite to the derivative. We give you the derivative, you give us the function. That's really what Calc 2 is. Instead of here, we give you the function, you give us the derivative. The other one will give you the derivative, you tell us what the function is. So let's prove the derivative tangent. I want to find the derivative tangent x. I want to prove that secant squared. Like I'm saying, I don't believe you. Just because it says in the book here, derivative tangent secant squared, how do we know this book is right? Well, let's see. Tangent happens to be, if you know your trig function is what? Sine of x over what? Cosine of x. That's what tangent is. So let's use the quotient rule. There's a fraction. I can use the quotient rule. Let f of x be sine of x. The derivative of that, what's the derivative of sine? Cosine x. Let g sub x equals what? Cosine of x. What's the derivative of that? Notice the ones with the c always have a negative in them. The ones begin with the letter c. Cosine, cotangent, cosecant. They all have a negative, negative, negative in them. Quotient rule says, oh, you want to take the derivative of that? According to the quotient rule, that's what? G sub x times f prime of x minus f of x times g sub prime of x, the whole thing divided by what? G sub x squared. What is g sub x? Cosine of x. What's f prime? Cosine x. Here's the minus. What's f of x? Sine of x. What's g sub prime? Negative sign. That'll make this a plus sine of x. I took the minus because that's a multiplication, made that a plus. All divided by what? Cosine of x squared. Because you got to square it. And the top, if you simplify it, that's cosine squared of x plus sine squared of x. If you took tech math with us at Stick here, we covered that trig identity. What's cosine squared plus sine squared? 1. Which really means 1 over cosine of x, the whole thing squared. What is 1 divided by cosine? Isn't that secant? That's secant squared x. That's where it came from. We can derive all of them, but I know you want to do them yourself. I don't want to take all the fun away from you. So let's mix some of these trig with the product rule, with the quotient rule, just to make sure you got it. And I know you're probably sitting in the back going, what am I going to use this stuff? Trust me, the application coming up.
Yeah, here. My brother-in-law's an electrical engineer who says he's never used calculus.
Calculus? Sure, for all the circuits problem, all the ones you do, maximum power transfer. I'm an electrical engineer. We do the maximum power transfer, all that stuff you have to use. Well, they derive the equation.
Yeah.
Once they derive, it's make sure. You want to make sure the load is half of, equal to ZQ or Z equivalent, whatever. But we use that in physics, find the minimum maximum stress. Actually, in this class, we'll show, like when you look at these balls, whoever designed these balls, you think they're designed by mistake to be that tall and that thick? No, because we want to minimize the amount of plastic we use. And that's the derivative. The derivative is the minimum maximum. What dimension will minimize, maximize? You'll see when we get to that. Like if I give you a piece of paper like this, I say, you know what? UPS said to you, design a box out of this paper that will hold the maximum volume, have a maximum volume. There's one height for this paper. If I cut a corner out of that to make it, that's only one size that will make this a maximum box. Any other dimension will not make it a maximum. And you'll see calculus comes in. So I'm going to cut corners from this box here. This cardboard, pretend that's a cardboard, it's paper now. It's a make-believe. Fold the edges. And now we have a box. And if, you're going strawberry picking this week, you want to get the maximum strawberries you can get in that box. I want to get a lot of strawberries. There we go. So my goal now to make sure that box has the biggest volume possible. What dimension I can make the box to give me the maximum volume possible? And that's calculus. So we'll do some of that. You want to graph a function without a graphing calculator? The derivative is one way of doing it. Because if you just pick points and graph the points, if you have any lump in it, any one of those hump that's not a 1, 2, 3, 4, because you're going to pick x equals 1, x equals 2, x equals 3, x equals 4. You're not going to pick 1.5, 2.7, 4.3. With the derivative, you will never miss these points. But just like anything else, you start doing a job and it's okay, just use this equation, it works. And especially if your job is the same thing every single day. So, okay, use that equation. That's what we're going to be doing. You're doing stress for a company, building bridges, whatever the case is. Make sure you use this equation. Boom. Plug it in. Yeah. But we'll show you the math behind it. Okay. Let's take this problem. Let's take the derivative here. Y equals, again, practicing quotient, product, taking derivative, but adding to it trig functions. Not to change the subject, I have a friend of mine who's the third highest probably person at Goldman Sachs. And I'm not making that up. His Christmas bonus 1 year was $30 million. He's in charge of buying real estate for Goldman Sachs. He said to me, the last 10 people I hired, now keep in mind, this is real estate, investment banking. The last 10 people I hired all were engineers. Because the way engineers think is completely different than the way most people think. He goes, I can teach them all the ins and outs of buying real estate, but I can't teach them how to think, because they approach it from an angle that I never even thought about. And my son, who is now consultant for Deloitte in Washington, D.C., he goes, I should have majored in math or engineering, because you'll be surprised some of the stuff that you do there, like the way you need your brain to think. And most people, if your brain is not programmed to think that way, you're in trouble. So just because we take in the calculus, people say, oh, I'm going to be like a biology major, or I'm going to be an engineer. Being an engineer doesn't mean you're going to be working in engineering. You could be doing investment banking. You could be a consultant for a company. You could be working for IBM. You could be working for Deloitte, going troubleshooting. You could be working for a powerboat company. There's so many branches, but that thinking, the way you get from math and physics and the science classes, that's the part they want to see. That's the part they look for.
So ultimately, what you're saying is they want to see people who can think abstractly and see something that nobody else does.
Yeah, kind of. Like, you know what? I'll tell you one of the examples they gave my son for his interview. How many golf balls can you fit in a plane? That's one of the interview questions. One of them, how many mattresses were sold in the U.S. last year? That was the interview questions.
How would you answer that?
That's when you think logically. You said, well, how many mattresses? How many people live in the USA? 200 million? 300 million? An average person changes a mattress every 20 years. So 300 million divided by 20. Okay, what's that number? Now, how many of these are married couple? You know, probably there's about 60 million married. That means they only need one mattress. And they start going through it, break through it, you know, slowly, and you see the logic behind it. And that's what they're looking for. It's not how many mattresses sold. If you go 10 million, they go, you're fired, get out. Because they want to see you thinking, how many golf balls can you fit on a plane? Well, the golf ball is almost an inch by an inch. Okay, that's a 1 cubic inch. A 747 has about, let's say, 200 rows or 100 rows. Doesn't matter if you're wrong, but just the way you think. You go 100 rows, 6 across. You know, each row there's about 3 feet between you and the other one. There's this wide. You can estimate what the size of the plane. Then you can say, well, divide the numbers, and that's how many. One of them actually goes, how many planes take off out of Dallas, Texas? Dallas Airport. I mean, in Arlington, in Washington, D.C. And he'd never been to Dallas Airport in Washington, D.C. He goes, well, how many terminals? He goes, assume there's 40. You go, well, if there's a plane taking off, assume plane comes in every 1 hour, one takes off every hour. That means one plane every 2 hours. If the airport opens for 12 hours a day, you got 2 hours for each takeoff, and you start to do the math that way. Goes, oh, I like the way you think. And that's how you have to approach it. They're not looking for an exact answer. They're looking to see how your brain actually solves that problem. Because if you're a consultant, you encounter a problem nobody ever seen before. And how are you going to solve it? I can tell you I have a problem on my computer right now. When I'm on DataTel registering people, I have 3 different browsers. One of them, when I type in my name, nothing shows up in the box. I go Z Haddad so I can log in, nothing. The other 2 works fine. The guy said, I've seen this before, I have no answer to it. Let me think about it. And he's thinking about it for 2 days now, trying to find a solution to it. Okay, back to this. I just put 5 minutes of nothing on the video. Stories. What's the derivative of this? That's the bad thing about the video. It eliminates how many stories I can tell, how much. What's the derivative of x? 1. What's the derivative of tangent x? Look at your cheat sheet for now. Secant squared. That's your answer. Let's try this one. Y equals x secant x. What do you see there? That's multiplication, product rule. Very good. You see x times secant of x. F of x is equal x. F prime of x, what's the derivative of x? 1. G sub x equals what? Secant x, what's the derivative of that? Secant tangent, yep. Doesn't matter which one you write first. So what's the derivative? dy dx. What do we have? The first, which is f, times the derivative of the second, plus the second times the derivative of the first. What's the first? X, g sub prime, secant x, tangent x, plus g sub x, which is what? Secant x times the 1. So if you clean it, what do we have? X, secant x, tangent x, plus secant x. I'm trying to spend a lot of time on this because if we're struggling with the product and the quotient, the next section is a nightmare. So I need to make sure your product and quotients are good to make the next section easy too. No, the product and the quotient. The other one when the power is different than 1. Like get x to the 5th times secant of x to the 7th power. You know? You guys okay there, Nick?
Yeah, I think so.
Go ahead if you're not sure.
Is that the answer right there?
Yep, the only thing you can do is factor out secant if you want, you know? Let's try this one. Okay, what do you notice? The first thing you see there? Quotient, fraction, exactly. So you see a fraction is the quotient rule. You go f of x, it's 1 minus cosine of x. The derivative of that, the derivative of 1 is what? 0 minus, what's the derivative of cosine? So that make it a plus sine of x, right? Because minus and minus will make it a plus. It's 1 minus, and the derivative of cosine is a minus sign. That'll be a plus sign. G sub x is what? Sine of x. And what's the derivative of that? Cosine of x, yep. Now the quotient rule says the derivative dy dx g times f prime minus f times g sub prime over g squared. Plug them in. Sine of x times f prime, which is what? Sine of x minus f of x, which is 1 minus cosine x, times what? G sub prime, which is cosine x, over g sub x squared. I can simplify that. That's sine squared x. Let's multiply. Let's only put a space there. What's cosine x times 1? Cosine x with the minus. I'm putting a space there. There's a reason. Trying to reshuffle them while I'm doing it, so I don't have to write it twice. And what's cosine times a cosine? And there's 2 minus sign. That'll make it what? Positive cosine squared x. What's sine square plus cosine square? So my answer is 1 minus cosine of x over what? Sine squared x.